Welcome to Differential Equations, Chapter 3, Section 4. In this section, we'll be discussing complex roots of the characteristic equation. So we have the general form ay double prime plus by prime plus cy is equal to 0. So in this case, in this section, we'll be discussing with imaginary numbers. So this means that in the square root, we'll have b squared minus 4ac. Whoops, I don't know why I put that up there. So the b squared minus 4ac is actually all a negative number. Remember, when we take the square root of a negative number, we get the imaginary number I. So we're going to be dealing with cases where we have these i's as our solutions. So if we had lambda is equal to, we'll just put the number sign plus or minus I. We'll actually add an a just for general case. The end solution will actually be, so we have the constants, and then we have e to the number t, just like last time. And then we have cosine of at, and then we're going to do the same for the next one. C2e to the number t, and then we're going to switch it to sine at. So let's actually start off by doing a problem from the Boyce DiPrima textbook. So in the text, we see we have y double prime plus y prime plus y is equal to 0. So just like last time, we can say lambda squared plus lambda plus 1 is equal to 0. So over off to the side, I'll just write out the quadratic formula. Over 2a. Okay, so we know a is 1, b is 1, and c is 1. So we can say lambda is equal to negative b, so negative 1 plus or minus square root b squared, so 1 minus 4 times 1 times 1 all over 2a, and 2a would just be 2. So this will actually go to negative 1/2, because we can split up those two, plus or minus the square root of negative 3 over 2. And this will actually be some imaginary value, so we can say negative 1/2 plus or minus square root of 3 over 2i. So now that we have both of these lambda values, we can plug it in our general format. So we'll have y is equal to, and then e to the number, and the number is negative 1/2, so negative t over 2. Then we say cosine, and in this case our a value is radical 3 over 2, and then I'll strap on the t. And then we can't forget about the, oh, I forgot the constant here, c1. Can't forget about the other one, so we have c2e to the negative t over 2 sine of radical 3 over 2t. And we can say this is our solution, the general solution for this differential equation. Now let's go ahead and do another example here. So the next one we have is y double prime plus 9y is equal to 0. So we're going to use the same thing. We can say lambda squared plus 9 is equal to 0. And we know that lambda is going to be plus or minus 3i. We could go through all of the quadratic formula, but just getting used to seeing things in this format, we can tell that they're imaginary. So now that we know that lambda is plus or minus 3i, we can put it in the format that we would like it. So we have y is equal to c1, and then technically we have a 0 out here, so we could have e to the 0t, but we don't need to include that because e to the 0 is always 1. So we can just say c1 cosine of 3t plus c2 sine of 3t. And this would be our general solution for this differential equation. We can also do this with initial value problems. So we do have one of them in the beginning of this section. We'll actually go and do that one quick. So the third problem, we have 16y double prime plus, subtract 8y prime plus 145y is equal to 0. And we have the initial conditions of y of 0 equals -2 and y prime of 0 equals 1. So we'll go ahead and do what we've done before. We're going to have 16 lambda squared minus 8 lambda plus 145 is equal to 0. So I'm going to write out the quadratic equation again. Okay, so we're going to say lambda is going to be equal to -b, so that's going to be 8 plus or minus square root b squared is going to be 64 minus 4ac. 4 times 16, we'll actually do that off to the side here. So we have 64 times 145. I'll actually get a calculator out here. Okay, sorry about the wait. So we have 64 times 145, which is going to be 9280, which is all over 2a, which is going to be 32. So now we know lambda is going to be 8 over 32. That is actually 1/4, plus or minus, and then we'll actually just compute this using a calculator. So we're going to get the square root of, actually I'll write this out, of -929216. And that is going to be over 32. And this actually goes to 1/4 plus or minus 96i over 32, which ends up being 1/4 plus or minus 3i. Okay, so that was a little difficult there, but we got it solved. So now we're going to put it in the general format because we know the two lambda values. So we're going to have y is equal to e to the 1/4. Whoops, can't forget the constant, sorry about that. C1 e to the t over 4. And then we're going to have cosine of 3t because of the 3i plus c2 e to the t over 4 sine 3t. So now that we have the initial values, we can plug these in. So we have y of 0 is equal to -2. So we'll say -2 is equal to e to the 0. So we're just going to get c1, and then cosine of 0 is going to be 1. So it's just going to be 1 times that. And then we'll just go ahead and skip this beginning for now. The sine of 0 is 0, so we can just say -2 is equal to c1. Now we need to take the derivative of this because we have y prime of 0 is equal to 1. So we can say y prime is equal to, and remember this is product rule, so we'll have c1 over 4 cosine 3t times e to the t over 4 plus, then the cosine of 3t is going to be 3c1 e to the t over 4 times sine of 3t. And remember, derivative of cosine is negative sine, so we'll switch this positive to a negative. And then the second half, we'll bring the e to the t over 4 down, so c2 over 4 e to the t over 4, and we'll keep the sine 3t. And then we're going to take derivative of sine 3t, so we're going to get c2 times 3 times e to the t over 4 and cosine of 3t. And remember, we're plugging in 0 for t, and this equals 1. So 1 is equal to, and we're plugging in 0 for t, so cosine of 0 is 1, so we're going to have c1 over 4. Sine of 0 is going to be 0, so we don't care about this. The sine of 0 is 0, so we don't care about that. And then this is just going to be 3c2. We know from above that c1 is negative 2, so we can say 1 is equal to negative 2 over 4 plus 3c2. So that's actually negative 1/2. So we're going to get 3 over 2 is equal to 3c2. We divide this by 3, and we get c2 is equal to 1/2. Oh, sorry about that. c2 is equal to 1/2. So we can say the final solution is going to be this, and then we're going to plug in these values. So we're going to have negative 2 e to the t over 4 times cosine of 3t, and then we have c2 is equal to 1/2, so plus 1/2 e to the t over 4 sine of 3t. And this is the solution for, let's see, where is it? This is the solution for this differential equation at the top of the page.